My name is Michele Muccini. I work at the Institute for Nanostructured Materials of the National Research Council in Italy. Active matrix display technology is a new technology for generation of light from organic thin films and can be applied as active matrix display technology. The benchmark technology is the OLED display technology, which is based on the use of a diode in which a stack of organic layers is placed between two injecting electrodes. When an external bias is applied, electrons and holes travel and recombine into the stack to generate light. This technology has already been applied for portable devices, and it is testing the market for large area TV sets. Also, demonstration for flexible display application has been reported. The OLED technology that I co-invented in 2003 is based on the use of organic TFTs for light generation. The key structural difference between the two OLED and OLED technologies relies on the fact that in the vertical diode structure, charges have to cross the different borders and the different interfaces of the layers constituted the organic stack. While in the OLED planar transistor, charges travel laterally until they recombine and generate light in the middle of the channel. If one wants to use the OLED for display technology, the intrinsic feature of the device architecture has direct implication for the manufacturing. In particular, complexity of the multi-layer structure results into severe manufacturing complexity and hurdles. The OLED device is a current-driven device, which requires high current density for driving and forces to use high-end TFT technologies like LTPS or oxide TFTs. Light outcoupling is inefficient, which has implication for high power consumption. The substrate for fabrication must be high temperature compatible, which has then implication for costs and flexibility. The diode structures require complex driving circuit for compensation. All of these issues can be addressed and potentially solved intrinsically by the OLED architecture. You can first of all fabricate the device with a fewer number of layers, which has direct implication for simplifying the manufacturing process. The device is not current-driven, but it is voltage-driven, which allows to use lower-end TFT technologies like, for example, amorphous silicon or organic TFTs. The light outcoupling occurs in the middle of the channel, and this has much higher efficiency than what happens into the OLED structure. There are no specific constraints for the substrate, and the substrate then can be virtually any one for device fabrication. The transistor structure allows simplification of the driving circuit for compensation into a real display application. In conclusion, the active matrix OLED display can find their way into the display arena. However, one has to consider that still fundamental questions remain to be addressed, and in particular, they refer to durability, efficiency, manufacturability. All of these issues and this topic is addressed and discussed into the first book on organic light-emitting transistors by Michele Muccini and Stefano Toffanin, edited by Wiley. Thank you very much.